Hello, for this particular video, we're going to learn how to find the vertex of a quadratic function when the quadratic function is given in standard form. And the standard form of that quadratic function is ax squared plus bx plus c equals y. The vertex is simply the x and y coordinates. And in order to find the x coordinate of that quadratic function, we use the following formula where x is equal to minus b divided by 2a. So let's use this example. Let's say we have a quadratic function. Okay, y equals minus 2x squared plus 4x plus 1. And I want you to find the vertex. Well, the vertex, like I said, we need the x coordinate. So when we use that, okay, if we go ahead and identify coefficients here, this is the a coefficient, okay, this is going to be the b, and that's going to be the c. But when we do the vertex, when we find the x coordinate of the vertex, we don't need the c coefficient, okay, we just need a and b. So we use the formula, okay, so we have x equals minus b over 2a, and then what I'm going to do is I'm going to plug in what I know here, my a and b. So my a, in this case, is going to be negative 2, and my b is going to be 4. So that just becomes minus 4 over 2 times, and we say a was negative 2. Okay. And that's just going to give me minus 4 over minus 4, and that's going to give me 1. So my x coordinate is going to be 1. Okay, so x equals 1. Now in order to find the y coordinate, what we do is we take the equation, okay, and what we're going to do is we're going to replace 1 for x. So every time you see an x, we're going to replace it with 1. Okay. Let's go ahead and plug everything in. So we're going to replace x with 1, and then now we're going to do the arithmetic to get an answer, okay, for the y coordinate. Okay, so basically, that's going to equal, let's see, 1 squared is 1 times negative 2 is negative 2. 4 times 1 is 4 plus 1. Okay, so negative 2 plus 4 is 2 plus 1 is 3. So remember the vertex. Okay, that's given as the coordinates of x and y. So since we know x is 1, okay, and our y value is 3, then that would be the vertex for that parabola. Okay, so one other thing I want to show you quickly on the next slide is the vertex, the quadratic function in vertex form, and how to find the vertex directly from that form. So let's go to the next slide and we'll talk about that. So here, the vertex form is going to be given by the following equation. Okay, and the vertex, like I said, is going to be identified with h comma k. And when you think about it, that's analogous to saying x comma y. So the h value is really the x coordinate, and then the k value is really the y coordinate. So let's look at an example of this, okay? So we'll just use this as an example. and then I want you to find the vertex. Okay, so what we want to do is we want to pay attention to this value here and this value here. And my h value is going to be this one, and my k value is going to be that. So when we find the vertex, okay, remember we want to find h comma k. So my h is going to be 1, and my k is going to be 3. And you're probably asking, well, why is it not -1? Okay, and I'll explain that actually. Let's go back to the vertex form of y equals a x minus h squared plus k. This is the vertex form that we had from up top. And then let's plug in the values of h and k. So h is 1 and k is 3. So in order to get minus h, okay, in order to get a -1, you notice that in orange I have x minus 1 squared. In order to get that, then h had to have been positive. It had to have been positive. Okay, and of course k is still going to be 3, right? And if you think about it, a negative times a positive 1, okay, is going to give me, let me go ahead and place the 2 with the a, because my original problem was 2, was 2 in parentheses x minus 1, so we're going to put that there, okay? And anyways, as I was saying, all right, this negative times a positive 1 is going to give me a -1. And that's where I got it from, okay? So you kind of have to think, what did they plug in for x in order to get x minus 1? Well, it had to have been a positive 1, because a positive 1 times a negative is a -1. So you kind of have to think of that in terms of the signs, okay? So we can do another one like this actually on the next screen. Okay, so remember, if this is in vertex form, okay, this is in vertex form, right? A times x minus h squared plus k, and then now what I want to do is provide an example. So we'll use this as an example. All right, and then we read the vertex. Okay, so the vertex, okay, remember it's h comma k. So this value here represents the h, and then this value here represents the k. So our vertex is going to equal, okay, -3, 4. Okay, and you're probably saying, why is it -3? Why is it always the opposite? Okay, all right, again, let's go back to the original problem. Okay, so the original problem that was given was 2 times x plus, and then, right, and we're going to plug in -3. Okay, actually, excuse me, let me erase the plus there. So look at the original equation in orange, right? It's x plus 3. How am I going to get an x plus 3? What do the signs have to be? Well, in order to have that happen, it's going to be a minus. Okay, and then I'm going to be plugging in a -3 here. Okay, and then the 4 is still the same. All right, and when you think about it, a negative times a negative is the only way to get a positive. So that h value had to have been -3. Okay, so we have to think, what do the signs have to be in order to get a +3? Well, it's minus minus in this case, negative negative. Okay, so when you simplify it, then you get this equation that we had. Negative times a negative is a positive 3 squared plus 4. And that's sort of matches up what we have here. Okay? So my vertex is indeed minus 3, comma 4. So finding the vertex in either the vertex form or the standard form is pretty straightforward. With the vertex form, you've got to be a little bit more mindful about the signs when you think about the h value. Okay? So I hope that this will help you and determine what the vertex is. Okay? All right. So now what I'm going to talk about is apply this to a real-world application problem and finding the vertex, okay, and how it relates to parabolic motion, you know. So on the next slide, we're going to do an example that will talk about that. So in this particular example, we want to find with the height of the ball thrown in the air is given by the following equation. And think of the initial location of the person is at 0, 0. And then the ball is going to come down at another point we will call x, 0. And x in this case is referring to the horizontal distance. Okay. All right. And when you think of that, think of it like this, that is you have this parabolic motion. It looks like that, right? And then along the surface, you have the horizontal distance, okay? And we want to know what that is, okay? So that's what we're going to calculate. All right, so the first step that we want to do is the question that I'm going to ask here is how high is the ball when it leaves the child's hand or a person's hand or whoever's throwing the ball, okay? So when you see a problem like this, it really doesn't matter who's throwing it, okay? Think of it as the ball's going to take a projectile path. It's going to take a curved path, right? And it's going to reach a maximum height as it increases. You know, it increases, it reaches a maximum height, and then it begins to head towards the ground, okay? So that's called a parabolic motion or a curved motion. Anytime you throw something in the air, that's the path it's generally going to take, okay? Because gravity is always going to take over once it reaches the maximum height, and then it's going to pull the object back down towards the ground. Okay, so just basic physics there. So let's go to the next slide, okay? And this is the first question that I'm going to ask, okay? So part A. Actually, let me go ahead and... Okay, so part A is basically is the question that's going to be generally presented. How high is the ball when it leaves the person's hand? Okay, so it's going to be a three-part question, and I'll break down each question for you. How high is the ball when it leaves the person's hand? So remember the original equation that we had, okay? So give me 1 second here. Okay, so we said it was, so it was hx equals minus 1 over 12 x squared plus 4x plus 5. All right, and so that's the equation that was represented, okay, by the height of the ball thrown in the air. All right, so what we want to do is basically we want to find y we want to find y when x equals 0. All right, so why do we want to set x equals 0? Well, the height of the ball is going to be at 0. Okay, so we want to set that equal to 0, or actually, excuse me, not 0. X is going to be 0. The x coordinate is going to be 0. Okay, and so if you think about it, hx, okay, the height, that's actually considered the vertical distance, and x is the horizontal distance. So if it's at its initial point, then x is going to be 0. Okay, and go back to the original slide here. Okay, you got to remember that this is 0, 0. So my x is going to be 0 in this case. And then it's going to land over here. It's going to travel a distance, a horizontal distance x. And the height is going to be at 0 when it hits the ground. So you got to think of like terms of like that. All right. So so basically what we're doing is we're going to replace x with 0. Excuse me, in this equation. Okay, sorry, I'm getting trapped with the colors here. So minus 112. Okay, and then we're going to replace x with 0. Okay. And then you just calculate. Now 0 squared is 0 times negative 112 is still going to be 0, right? 4 times 0 is still 0. So my y is going to be 5 feet. Okay, so the units we're going to be using is in feet, by the way. Okay, so units in feet. All right, so the left FYI. Okay, so basically what we're saying is that when x is 0, my y value is 5, right? Because that's how a coordinate is written. That's how a point is written, right? I need the x and the y coordinate. So initially my x is 0, my distance is 0, and then it's going to travel through the air, right? And it's going to reach a height of 5 feet and then come back towards the ground. Okay, so that's going to be the first question that you generally will see. All right. My next question here, okay, is this question: what is the maximum height of the ball? So the key thing that we're going to realize here is that we're going to set y equals 0, okay, and we're going to do that and basically is to find the max height or the maximum height. Okay, set y to find the max height. And the reason being is because we need to consider the height at the end, which will be 0 feet. Okay, so that is the reason, why we need to do this. Okay, and that's going to basically determine how the problem is going to be set up initially, right? So keep that in mind. Okay. We said would be 0 feet, right? Okay, so again, right? Remember our equation? Y equals negative 112 x squared plus 4x plus 5. You remember that? So the max height is going to be, we need to find the vertex, right? We need to find the vertex of this, okay? Because we have a quadratic function that's in pretty much standard form, and we want to find the vertex from that standard form. Now remember what I said, the vertex. Remember the vertex equation? Remember we said that it was x equals minus b over 2a, okay? Now, in this particular problem, the x coordinate, right, it's actually, you're actually, you got to think of it as time, okay? Because as soon as you throw the ball, it's going to take a certain amount of time to reach that maximum height and then go back to the ground again, okay? So as it's traveling that horizontal distance, right, as it's going up in the air, it's covering horizontal distance, right? And that is the time it takes to reach that maximum height. And then it'll start to curve back and head down to the ground. So before we do this is that we need to, like I said, we got to set y to 0. So let's go ahead and do that, right? Y is going to be 0. Okay, and that's the height that it's going to be once it reaches its, once it reaches its maximum height, it heads back to the ground, comes at rest again. Y will be 0 at that time. Okay, and now we can read the coordinates off. Okay, remember that this is your A, this is your B. Okay. So we're going to plug it in. Let's plug it into the equation over here. So we have minus, we said B was 4, right? So it's just minus 4 over 2 times minus 1/12. Okay, so when you do that, all right, this is just basic arithmetic, okay? Again, that's just going to be minus 4 over, now 2 times negative 1 is negative 2 over 12. Okay? And then you just divide these out. So when you do that, you're going to get, remember, minus 4 over 1. Okay? Divided by minus 2 over 12. And when you do the keep, change, flip, okay, so you got minus 4 over 1 times minus 12 over 2, and then you cross cancel the 2 with the 4 and you get 2. So negative 2 times negative 12 is going to give me x equals 24. So that is, remember now, keep in mind that x is going to be t, or time, in seconds. Okay, so this is really 24 seconds. All right. So the x coordinate is the time it takes to cover the distance along the x-axis, and that's what that is. Okay. So now we can plug in the x coordinate, the x value, back into this equation and get me my y value, and the y value is the vertical distance, and that tells me the maximum height that this will be. So this will just be basically, you're going back to your original equation, all right, which is minus 1/12, and again we're substituting 24 here, okay, for x, and we're doing that to solve for y. Okay. All right. And negative 1/12 times 24, okay, is going to give me minus 48. And then, of course, 4 times 24 is 96, plus 5. And when you do minus 48 plus 96 plus 5, you will get 53. So 53 feet will be the maximum height. Sorry about that. Let me write that a little bit better. Okay, let me just use a different color here. So yeah, your y is going to equal 53 feet, which will be your maximum height. So yeah, there's a little bit of a calculation involved, but remember your y value is your maximum height. Okay? That's why we're solving for it. So you have to get the vertex, you have to get that x-coordinate, and that's going to tell you the time it takes, because time is always along the x-axis. It's an independent variable, so it's always on the x-axis. So the x correlates to the time in seconds it's going to take for that ball to reach its maximum height. Plug that value back into the standard form, the equation that's given, minus 112x squared plus 4x plus 5, as I did in the bottom here, at the bottom, and then you'll get 53 feet, which will yield its maximum height. So what is this problem saying? It's telling you that it's going to take 24 seconds to reach a maximum height of 53 feet. Okay? Okay. Okay, so let's look at the next problem here. Let's go to the next, not next problem, but the next part, right? That's what I meant to say. Okay, so the last question, the last part is how far from the person does the ball strike the ground? So we're going to remember x is the horizontal distance, okay, that it's going to travel, okay? It's going to start at an initial point at 0, 0. That's where the person is standing. Ball's going to go in the air and then strike the ground at a new point, which is going to be 0, x, 0. And the y is 0 because the height is 0 because it's on the ground. Okay. So in order to do this, again, we're going to set 0, set y equals 0. All right. And gotta remember if that was the equation we used. Yeah, I think that was. Okay, so anyways, okay, so we're gonna make this quadratic function a little bit easier to work with. Okay, so we need to make sure that the x squared coefficient, this is the a coefficient, positive. So we're going to multiply both sides by negative 12 to make the x squared coefficient positive. So, so let me go ahead and write that down. All right, so here's what I'm going to do. I'm going to take 12 and I'm going to multiply it both sides, okay? Oops. Okay, so this will make things a little bit easier when we do that. So let's go ahead and calculate this and see what we get. Okay, so 12 times 0 is 0. Okay, so these 12s will cancel, and then you're just left. Now don't forget, I meant to say minus 12. So put a minus here, and a minus there, and a minus there, and a minus there. Okay, so again, negative 12 times 0 is still 0. All right, the two negatives here become a positive, and the 12s cancel, so you're just left with x squared. Again, I keep messing up the colors. X squared. A positive and a negative is a negative, and then 12 times 4 is 48x. Positive and a negative is a negative. 5 times 12 is 60. And now we have a quadratic function that we can actually solve a little bit easier, okay? So, how do we do this, okay? So what we want to do is we want to use the quadratic formula, okay, so that we can get the x coordinate, and we want to solve for x, okay, because we already set y to 0, all right, and now we're going to solve for x. So what we did is, in order to solve for x, we're going to have to use either the quadratic formula or see if this is factorable, okay? So we'll need to check that, because if we can't factor it, then we need to use the quadratic formula, okay? So, and we're going to look at this, and then we're not going to be able to factor this, because there are no two factors that add up to 48 when we find all the factors of 60. So we have to use the quadratic formula, okay? So remember that the quadratic formula, okay, if you remember that basic formula, okay, so that's going to give me, that's going to give me x equals minus b plus or minus square root of b squared minus 4ac. And that's all over 2 times a. All right. So when we do that, again, your coefficients here, don't forget, will be a equals 1, b equals minus 48, and c equals minus 60. Those are the three coefficients that we need to plug in. So let's go ahead and do that and see what happens. Okay, so again, minus, and b is minus 48, so we need parentheses around that. And b squared is minus 48 squared minus 4 times, well, a is 1 and c is going to be minus 60. And we know this is all over 2 times 1, which is just 2. All right, so let's go ahead and simplify this and see what we get. So this is going to be positive 48 plus or minus. And let's see if we can calculate that on a calculator to speed up process here. So 48 times 48 is going to give me 2,304. Okay, because a negative and a negative is a positive. Now don't forget, a negative 4 times 1 is a negative 4 times a negative 60 turns into a positive, okay, 240, right, because you got 6, 12, 18, 24, and you had the 0, so 240, all right, and then that's all over 2. Okay, so this is going to give me 48 plus or minus square root. Now we add 2304, right? And then go ahead and add 240 to that, right? and you're going to get 25/44 all over 2. And we need to find the square root of 25/44. So we'll do that. And then we get 50.438. And we're going to divide that by 2. So we have 2 answers here. Let's see which one works, okay? So here we go. So the first one, you can write this as x equals 48 plus 50.438 divided by 2. And then the other answer is going to be write it down here, x equals 48 minus 50.438 divided by 2. So let's see what we get. Okay. Again, so we got 50.438, right? And then we want to add 48 to that, right? And then we want to divide that by 2. And I came up with 49.219. Again, all these measurements are in feet now, okay? So look at that. Now, the other answer we're going to disregard because 48 minus 50.438 is going to give me a negative value. And even if I divide it by 2, it's still going to give me a negative value. And distance is never measured in with a negative value. So we're going to exclude that answer. We're just going to totally ignore it. Okay. And so this is going to be a no, simply because the distance cannot be negative, okay? And that's the reason why I'm going to ignore that answer entirely. All right, and just choose the positive answer instead. So this is the one that we want. Whoops. That's the one we want. Negative 49.219 feet, or 49.2 feet. You round it up, around it, the answer, okay? And that's what I have for that. So that's how high the ball is going to be. It's 3 parts. That's how far the ball is going to be when it strikes the ground from the initial location of the person throwing it. All right. So I hope that this problem will help you with quadratic functions and finding the vertex in standard and vertex form. Thank you so much for watching.